An NMOS transistor operating in linear region has IDS of 5 microampere at VDS of 0.1 volt. Keeping VGS constant, the VGS is increased to 1.5 volt. Now, given that mu1 Cox W by L is 50 microampere per volt square, the turn conductance at new operating point in microampere per volt. Easy question, but a tricky question. If you will not be careful, then you will solve it wrongly. So with the first information, they have clearly given that MOSFET is operating in linear region. So firstly, with VDS is equal to 0.1 volt and linear region of operation, they have clearly said that this MOSFET is operating in linear region with VDS is equal to 0.1 volt. Definitely your VGS minus VTH will be greater than this VDS value. When VDS is less than VGS minus VTH, or we can say that VGS minus VTH is greater than VDS, then your MOSFET operates in linear region. And in linear region, current is given by IDS is equal to capital Kn 2 into VGS minus VTH into VDS minus VDS square. Okay. Here VDS is known, Kn is known, IDS is known. So I can find out the value of VGS minus VTH. Why I should know the value of VGS minus VTH? Because in the second case, keeping VGS constant, VDS is increased. So if VGS is at the same value and threshold voltage obviously for the MOSFET will be constant, then VGS minus VTH for the second case will be at the same value, just VDS is changed from 0.1 to 1.5. So I must know the value of VGS minus VTH for the second case so that I can find out the answer of second part. Okay. So Kn, where Kn is mu1 Cox W by 2L, IDS is given as 5 microampere. Okay, 5 microampere. Okay, Kn is mu1 Cox W by 2L. Mu1 Cox W by L is 50 divided by 2. This is in microampere per volt square, and this is in microampere. So microampere got cancelled out. So this bracket thing should be in volt square, because this is in microampere per volt square, this should be in volt square, so that microampere per volt square into volt square will be microampere, and this is in microampere, so microampere will be equal to microampere. Take care of the unit always. And capital Kn is mu1 Cox W by 2L. You are given with the value of mu1 Cox, which is 50. mu1 Cox W by 2L will be 50 by 2. mu1 Cox W by L is 50 divided by 2. And there is 2 into VGS minus VTH. We don't know this value. VDS is 0.1 minus 0.01. Now, this is, take this 10 upon 51 by 5. 0.2 is equal to 2.2 into VGS minus VTH minus 0.01. So, 0.2 into VGS minus VTH is equal to 0.21. So, what is the value of VGS minus VTH from here, from the first information? 0.2n upon divided by 0.2. This is 2.1 divided by 2. This is 1.05 volt. This value is fixed because VGS is constant for the second case. So this VGS minus VDS will be same for the second case also. Okay. Now, you have increased the VDS value from 0.1 to 1.5 volt, while VGS value is at the same value as in the first case. So VGS is at the same value, VTH is at the same value because VTH will be constant throughout. So VGS minus VTH will still be at 1.05 volt. Now for this case, we can clearly see that VDS is greater than VGS minus VTH, because, and for the first case, VDS was 0.1 volt, 0.1 volt was less than 1.05, less than VGS minus VTH. That's why in first case your MOSFET was in linear region, but in second case, as your VDS is greater than VGS minus VTH, you will be in saturation region of operation. And you are in saturation region of operation, therefore the transconductance GM is given by 2 capital Kn into VGS minus VTH, where capital Kn is always mu1 Cox W by 2L. Put the value 2 into mu1 Cox W by L value is 50 divided by 2, because capital Kn is mu1 Cox W by 2L. So mu1 Cox W by L is 50 divided by 2 is 50 by 2. Okay. So this is in microampere because 2 is unitless. This is microampere per volt square. So if I will put the VGS minus VTH in volt, microampere per volt square into volt will give you the unit of this transconductance as microampere per volt, and the answer is also asked in microampere per volt. So put the value of VGS minus VTH, which is same as 1.05. We'll get 50 into 1.05, which is 10.5 into 5, and we'll get the 52.5 microampere per volt as your answer. What is the answer? Is 52.5 microampere per volt. Answer. Okay. Let us discuss the next question, and I think this is the final question. Okay. Let us solve it. Okay.